This is going to be a fairly short video going through how to balance equations and also what equations show. So I've got an example equation here. This is methane reacting with oxygen to form carbon dioxide and water. This is an example of complete combustion, and we can tell that because it's a fuel reacting with oxygen to make CO2 and water. So the carbon dioxide present tells us that this is complete combustion. Now what we need to do is we need to balance the equation, and that's because all reactions follow the law of conservation of mass. And what that means is that atoms cannot be created or destroyed. The bonds between molecules break, the atoms rearrange, and new products are formed, new molecules are formed. So any atom that's present on the left-hand side of the reaction has to be present on the right. And we can't get new atoms from anywhere or get rid of atoms in a reaction. So if we look at the left and right of this equation, we can see that on the left-hand side we have carbon atoms, hydrogen atoms, and oxygen atoms. And on the right-hand side we also have carbons, hydrogens, and oxygens. Now I've put them in the same order so that we can compare the numbers of each of these atoms on the left and on the right. So on the left-hand side we have CH4. Now CH4 is telling us that there's 1 carbon and 4 hydrogens. And in chemistry we don't include the 1 in the chemical formula. So on the left we have 1 hydrogen at the moment. Hydrogens, there are 4 because it's CH4, and oxygens there are 2 because it's O2. On the right hand side, CO2 is the same as C1O2, so we have 1 carbon at the minute, so the carbons are currently balanced, the atoms of mass has been conserved. But because it's H2O, we only have 2 hydrogens present on the right. And if we look across our products, CO2 and H2O, we've actually got 3 oxygen atoms. So at the minute, this reaction is not showing conservation of mass, because 2 of our hydrogens have seemingly disappeared because we've gone from 4 to 2, and we've actually ended up gaining an oxygen from somewhere, and that can't happen. So what we need to do is actually work out in what ratio the methane and oxygen react together, and in what ratio the carbon dioxide and water are produced to ensure that we do have conservation of mass. So to begin with, we can see that the carbons are already balanced, so we don't need to do anything with those. Now with the hydrogens, we've got 4 hydrogens on the left and 2 on the right. All 4 of those hydrogens need to react. So if we start off with 4 hydrogens on the left, what it's telling us is that 2 water molecules must be made. Now me putting a big 2 in front of that is like writing H2O plus H2O. I'm timesing everything after the big number. So what I've done is I've made 2 water molecules instead of 1, which means that on the right hand side there are now 4 hydrogens, because we have H2O plus H2O, 2 plus 2 is 4. But what we've also managed to do there is that we've got 2 oxygens from the waters now, and those 2 oxygens added to the 2 from the carbon dioxide mean that there are now 4 oxygens on the right hand side. So balancing the oxygens next, if we are making 4 oxygens on the right hand side, or we're getting products with 4 oxygens on the right hand side, we have to start with 4 over here. And that means that we need to start with 2 oxygen molecules. And again, that's like writing O2 plus O2. So that means that we have 4 oxygens starting on the left hand side. And now you can see that we've got 1 carbon on the left, 1 carbon on the right, 4 hydrogens on the left, 4 hydrogens on the right, and 4 oxygens on the left and 4 oxygens on the right. And that is a balanced chemical equation. In addition, what this is telling us is that 1 molecule of methane reacts with 2 molecules of oxygen gas to form 1 molecule of carbon dioxide gas and 2 molecules of liquid water. And just to do another example, in this example we have barium hydroxide reacting with hydrochloric acid to make barium chloride and water. I have just realised I have missed a 2 there. Barium hydroxide has 2 hydroxide ions. Apologies. So we've got barium, oxygen, hydrogen and chlorines. Now the oxygen and hydrogen are together in the hydroxide ion, but they are separate elements, so they need to be listed separately. And hydrogen is here twice, but we only need to put it in our list once. On the right hand side we've got barium, we've got the oxygens, we've got the hydrogens, and we've got the chlorines. So we do have all of the same elements on the left and on the right. On the left hand side we have 1 barium, and on the right hand side we have 1 barium. On the left hand side there are 2 oxygens, and that's because the 2 outside the bracket times everything inside the bracket by 2, same as in maths. On the right hand side we've only got 1 oxygen to begin with. Hydrogens, we've got 3 at the minute on the left hand side because there are 2 from the barium hydroxide because of the 2 outside the bracket, and then 1 hydrogen from the hydrochloric acid. And on the right hand side we have 2 hydrogens because of H2O. And chlorines, we have 2 chlorines. Oh, we don't. We have 1 chlorine, I can't count. 1 chlorine on the left hand side and 2 on the right. Now barium chloride is BaCl2 because of the ionic formula. And I do have a separate video going through why barium chloride, for example, is BaCl2 and not BaCl. So where do we start with this? Well, if we look, we can see that there are 2 chlorines on the right hand side and only 1 on the left. I'm going to start with these first because if I was to go with the oxygens or any of the others, it might get a bit complicated. But there are many routes to do this, so there's no particular set way. But I'm going to start with the chlorines. If we're ending up with 2 chlorines on the right, we have to start with 2 chlorines on the left. And the only way to do that is to start with 2 hydrogen chloride molecules. That would give us the 2 chlorines that we need, because remember this is HCl plus HCl, 2 hydrogen chloride molecules. Now, although we've got 2 chlorines here, we've now changed the number of hydrogens. We've added an extra hydrogen. So we've got the 2 hydrogens from the barium hydroxide as well as the 2 over here from the hydrogen chloride. So we've now got 4 hydrogens in total. Now, because I've changed the number of hydrogens here, we need to make sure that we've got the same number of hydrogens on the left hand side. And on the right hand side, I've got 4 hydrogens on the left and only 2 on the right. And all of the 4 hydrogens on the left hand side need to end up being used on the right. So if I put a 2 in front of the H2O, remember that means H2O plus H2O, 2 lots of or 2 times H2O. That now means that we've got 4 hydrogens on the right hand side. All of the hydrogens have been used. 4 on the left, 4 on the right. And what we've also done there is added another oxygen. So now on the right hand side, we've actually got 2 oxygens. And if we look, 1 barium on the left, 1 on the right, 2 oxygens on the left and on the right, 4 H's on the left and on the right, and 2 chlorines on the left and on the right. So mass has been conserved and that reaction is balanced. And what we've worked out there is that the reaction has to occur with 1 molecule of barium hydroxide reacting together with 2 molecules of hydrogen chloride to form 1 molecule of barium chloride and 2 molecules of water. And they'll always react in that ratio. If you don't have 1 barium hydroxide and 2 hydrochloric acids, then the reaction won't work properly. Any questions, send me a message and I'll do what I can to help.